Hello, Rome. Hi, guys. Hello. Hey. How's the conference going for you? Good. Okay. Great. So this is the last tag, I guess. Welcome you. So easy microservices in cloud with Kubernetes and Istio. Just before we enter the talk, how many of you are actually doing Kubernetes microservices here? Few of them. Okay. Kubernetes. Couple of them. Okay. So this talk is like, it has a basic points also, and it also goes to slightly advanced and the best practices. That's what we're going to see today. So let's go ahead and see what we have here. So a little bit about me. I'm Sendil Kumar. You can reach me at that Twitter handle. I'm basically from southern part of India, Tamil Nadu, and I currently live in Netherlands. So this is where I live. I'm a full stack developer at a company called Xebialabs. You can see it in my t-shirt too. So they're a DevOps-based company. I'm passionate about open source. You can see me contributing to many open source projects. I'm a part of JHipster. I'm core dev team member there. So where we decide the future of the entire full stack application generation. You'll see what JHipster is all about at this talk. I'm also a team member at Webpack. How many of you are front-end guys here? Nobody? Nobody? Okay, great. I'm also part of Rust and WebAssembly. You guys might like WebAssembly because WebAssembly is like bringing your backend to the front end, running your native code in your browsers. So I'm also part of the team member there where we are trying to port Rust code into that run in the browser. So that's Rust WebAssembly project. So microservices, since many of you guys are working on microservices, can somebody describe me what is a microservice? No? 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 One? Okay, so how many of you say every services in the microservice should have its own database? Every service in the microservice should have its own database. How many of you say that? One, two, okay. How many of you say against it? Nobody? 50-50? Okay, there is a poll going on right away, so you can, if you want, you can just go ahead and answer that in Twitter. So microservices, what are they? So I would like to think microservices in this term. So you had a problem. Once you have a problem, obviously, as a developer or a software engineer, what do? You go and create some solution for it. You create an application for it. And then you have many problems, and your application actually grows up. And what happens eventually? You have many more problems, and your application blows up. So this is what is a monolith, right? So you have many solutions that is put together inside the same component. And then you realize there are a lot of problems lying inside here. You want to split that out. So what we did, we shrink that application, and then we added few more applications surrounding it. You can call it as microservices or just services. You added multiple components surrounding it, and all those tend to form a single application, which we call it as microservices. And these services running anywhere in the cloud. It can be at your private data center, it can be at any cloud or a hybrid cloud also. But why microservices? Since you guys are doing microservices, why microservices? Why did you go to microservice? Sorry? More control of the different services, correct? Any other? Okay, easy to deploy. Exactly. Easy to deliver to your customers, yes. Scalability, yeah, of course. Yep. So obviously we went to microservices because it has a lot of advantages. Let's just see a brief overview of it. You get the concept of individual development. So each microservice, it's its application by its own. So you can develop it individually. And you can do individual deployment. So any service, as you said, it's like you can deploy it anywhere, you can run it anywhere. So it's individual deployment. And fault isolation. This is one of the coolest thing. In terms of monoliths, once your application services, some part of your application is not behaving correctly, your entire service will be down. Your entire service will have an impact. But in terms of microservices, you can just isolate that particular part and then recreate those parts. So that's one of the coolest features of microservice. And scaling, you can scale a service up and down, in and out, so you can do that stuff. All right, so microservices. That's this many advantages. Can we all start doing microservices now? Yes? No? Yes? No? Okay. Wait, there are some complexities in the microservices area. So there are certain areas or certain complexities when you start developing microservices. Let's see what are those. Just before we see what that is, I'd like to quote this quote. It's from Martin Fowler and James Lewis. So when we talk about microservices, of course, we have to end up in quoting them. So it's like, this is the quote. I don't want to read the quote, but I want to show a visual representation of the quote. So this is what. So consider you have a monolith, that's a bigger one, and your microservices, list of smaller stuffs there. In terms of monolith, your application, your problem lies at your monolith. So the monolith is, the problem lies inside your application code. Whatever problem that you're faced in monolith is because that you have written that code, it's your fault. But in terms of microservices, even if you have written super code that runs perfectly in all the situation simulations that you have created, the problem lies between those services, that is the network. And it's very difficult to manage that thing because we are not going to write TCP layer once again for every application that we are going to do, right? So there is some problem obviously living in the network, so you have to take that into consideration. And of course, you have this high availability. Whenever services go down, you have to boot it up again whenever things go down. We had a problem when we are doing monoliths. We had a problem to give high availability. But when we move to microservices, we are going to give this high availability to each of the services that is running, which is also one of the problems that you have to take into consideration. And then service registries. So it's like when you're doing microservices, you need to have a list of service registries that has to work there. And this service registries are some component or boilerplate code that you have to rely on. How many of you use service registries here? The microservices people? No. 1, 2, yeah. So you have limited number of options, but again, all those service registries that you're going to write, it has to be highly available again, and you have to maintain that code. It's a third-party application, or you have to write your own, which is very complex. So that is a problem that you have in microservices. And then health checkers. Again, you have to know each and every service, whether it's live or not, whether it's working or not, whether it's responding within your SLAs or not. So once you have that metrics, then you have to boot up additional services based on the requirement and all those things. Then health checking also forms the basics. And health checkers are essential for your microservices, but again, it adds complexity in your system. And then finally, deployments. We have seen the deployment is an advantage, but there is a disadvantage in deployments too, because when you try to deploy your services, you might not know whether you have to run it in a canary deployment or blue-green deployment or whatever the new terminologies that is coming in. At some point of time, you will be frustrated with the amount of services that is running outside the containers, and you don't know which services are up, which services are down, which version of services is going, running, and things like that. So that is one other complexity. And finally, the integration test. So it's not feasible when you have thousands of services to write integration and test it on your machine. It's very, very difficult because you cannot spin up thousands of servers in your machine. That's a difficult task to do. And maintenance of those projects. So these are the complexities that we have. So we had a lot of pros there, and we had a lot of cons there. Of course, it's a way of life. In life, everything has its positive and negative, right? But I would suggest, like, when you're trying to develop application, start with monolith because you can experiment faster. You don't like certain component or you don't like certain way in which your application is running, you can change those things. And then once you understand the business, or once you understand the segregation of your business, once you can separate those concerns, then probably you can move to services or microservices. There are services that are microservices or services. I would stick with services, but if you wanted to call it as a microservices, yes, of course. Okay, this is the second part of the talk. What is JHipster? Anybody here used JHipster? Okay, couple of people, great. So JHipster is nothing but Java hipster. JHipster is an application generator people used to call, but I would like to say it as a development platform. It kind of helps you to generate, develop, and deploy modern web application. So that's what JHipster is all about. It creates an entire suite of application with front end, with a back end, with database management, microservices, and things like that. And it's pretty easy to work with. But we have taken some opinionated approach in order to deliver those features because there is a wide variety of features available. But it kind of helps most of the enterprise customers or most of the people who want to start exploring or experimenting things. And we decided once we started doing this stuff, people come back and ask like, okay, so you have enormous amount of options, how we can simplify this workflow, how we can change everything that we can do. Then we thought of it and went to JDL. So what is JDL? JDL is nothing but JHipster domain specific language. We are going to create the application with this JDL, and I will walk through this entire JDL framework, how easy it's for you to create an application and things like that. But just before that, what a JDL can do, it can create your application or applications, it creates entities for you, and it creates entities with relationships for you. So you can create your tables and your application with JDL. So let's see some JDL in action, and then we go ahead and generate applications based on JDL, with JDL. So for creating an entity, again, any JDL or any description, domain-specific language is separated by spaces with some parentheses. It's similar here. But what we have here is like you specify entity keyword followed by the name of the entity and list down all the fields inside. It's more or less similar to your database structure. So for example, a country entity, you can define it something like this. You can say like entity country followed by the things that you have it here. And you can also add in validations for your entities. So that is also one other thing that you can do, add in the validations. And then you can specify relationship among entities. So those are the things that is with respect to entities. And then for application, you just have to specify application tag and then specify a config there. So what it does is like it takes all the default options that we provide and generates an application. But if you want to drill down and change certain things inside, you can go ahead and change them. For example, the application type that we support are monolith, a gateway, and a microservice. I'll tell you what's the difference between gateway and microservice, but let's have it that way now. So you can specify an application type there. You can, okay, so most of you, I guess you will be doing Java programming, so these are the basic things that you need when you generate a Java stuff. So the base name of the application, the package name. And then we also give database related stuff. We have support for SQL and NoSQL, so you can generate anything here. So it's SQL or NoSQL database for your production. You can define a cache provider there. And you can specify what kind of build tool that you want to do. How many of you use Maven here still? Okay, a few. Gradle? Okay, great. And then you can also specify the front-end framework here. It can be Angular or React, so you can specify any of this thing here. And then once you have the application config, you can specify the entities for those applications together. So that's how you define an entire application with JDL. And you can stack these applications together. So once you stack this application together, you obviously get a microservice. So let's see microservice with JHipster. Any questions so far? Questions? Okay, great. So I'll just say the pattern that we have in microservices or the architecture which we generate, and then we straight away go to the console and then start generating applications. So the pattern that we are having is the API gateway or BFF pattern. BFF pattern, anybody knows what that is? Okay. So BFF pattern is called as backend for front-end pattern. So you have one single backend that has the front end, but the remaining all the services that runs in the wild don't have any front end attached to it. And we also specify that entire application is API based, which means you can use this entire application that we're generating as an API gateway too. That is one of the cool use cases you can get. So how does an application look like? So you have obviously your clients or the endpoints from which the requests are flowing in, and it goes to your application. I said like there is one application that has a front end, so this is a front-facing application, so it goes to that application. And of course, the application has Angular or React-based front end, so you can connect to them, and user authentication happens inside that application, and followed by that, Zool proxy is there. Anybody here use Zool proxy? Okay, a couple of people. So Zool proxy is like proxying your request from an incoming source to the underlying source that is available. So obviously you have microservices that are running on different port, different machines. Zool proxy kind of helps you to connect or proxy this request from your main gateway into the services that is running at the backend. So this entire structure which has the front end in it is called as microservices gateway. So this is what I was talking about. So which has a front end in it is called as microservices gateway because it obviously acts as a gateway for your application. And from your gateway, your application connects to various microservices. So you have a list of microservices that is running in the wild. But one other thing is like these microservices may or may not have database attached to it. It's up to you to choose. Whether you want to have a database, whether you want to have a different database, you can choose it. But of course, in microservices land, we always need service registries and health checkers. So we do have options for that. So all this connects to service registry. So we have a couple of options for you to choose. One of them is console. Anybody used console here? Okay. Okay. So, Eureka, Netflix Eureka. Okay, there are a couple of people. Great. So Eureka, so JHipster registry is basically based on Eureka, which is Netflix open source model. So they have open source services. So then JHipster registry is available as a Docker image, as a complete package. It's an open source project again, so you can download it and use it. So what it does is like it does health checking as well as service registry. On the other hand, console is from HashiCorp. That's also an open source stuff, but you can use it. So the main difference between console and JHipster registry is console, we have consistency over availability. And in JHipster registry and Eureka, it's like availability over consistency. So it always, in terms of console, it always checks before going, sending the request to there. But in terms of JHipster registry, it sends a request because it believes that application is running and things like that. And console is running on all these services that you have. It's like the agent is running on all the services that you deploy, but JHipster registry lives single stuff. So it's like a single endpoint where all applications will communicate, but in terms of console, all your services will have its own there. And finally, we have console. Anybody uses ELK stack here? No. You know about it? ELK? So ALK is Elasticsearch, Kibana, and Logstash. So we built some framework on top of it, and we're using the JHipster console, which kind of like acts as a console for your DevOps side of team. So let's go and see JDL in action. Great. So I have created this JDL just to make sure that we are there. So you can see I have 4 different applications here, 1, 2, 3, and 4. And then I listed down all the entities here. So let's go and see the application. So as I said, an application structure should consist of a config and entities. And inside config, you can see the name, and it's basically an e-store application. So you have 4 different applications here. And this application type is a gateway. So this is your front end of your application. And you specify the package name. You specify whether you need a service discovery or not. You can use what kind of authentication, whether it's session or JWT and things like that. The database, of course, and the build tool Gradle, client framework, the front end, React, and if you want to add tests here. So this is how you define this entire application. And similarly, I have another application, and this application is called as product. And this product has its own list of things, but this is a microservice. So that's a basic difference between those 2 applications. One is gateway, the other one is just the service. And here I have a bunch of things similar to that. And then and then the third application is an invoice application, and it also uses MySQL database here. And the exciting one is the 4th one, which is notification, and it uses MongoDB here. So it's like 4 different applications that are running, and one has the front end, and remaining all 3 doesn't have anything else added to it. And as you can see here, the 4 applications, the first application, which is your front end, we are going to have all the entities that has to be generated for the front end. So we have specified star, which means whatever entities that you specified in this file will be generated, a front end will be generated for those things. And then you specify a particular entity for that application. So a product has this 4 entities. So you have specified these 4 entities here. And an invoice application has these 4 entities and things like that. And a notification entity just have one entity notification. That's it. So again, it's a basic thing. I'll just share this JDL script with you guys. You can go through it later. But it's a similar thing with just a lot of tables around. So probably a structure of the table will be something similar to this. It's very small, but so this is how the table structure is, and I'll share this and the application later in my GitHub repository. Great. So just to give an overview, I will create a directory. copy that app.jdl here. And all I have to do is like JHipster import JDL and app.jdl. And what it does is like it generates an entire application, creates a folder that are necessary, initializes Git and all the repositories, creates all those configuration file for you, and runs all those things. So your application is ready. It's bootstrapped and it's ready to do all the services that you need. So this will run for some time. I will just go back to the slides and come back here. Great, so that is what JHipster is all about. So it creates everything out of the box for you. So you can go ahead and configure. Again, it's like once you've created, you're not binded to that application generated. You can go ahead and change whatever things that you want to change inside there because it's just normal best practices followed Spring Boot based application. That's it. Kubernetes. So we have seen few people use Kubernetes here. Anybody enjoying it? Okay, great. We have one person. Great. So Kubernetes is an open source system from Google, and it's for automating deployment, scaling, and management of those services that you have. And it's basically for containerized application, and it's becoming the de facto standard of containerized applications, right? So anybody know what a pod is? Pods? Yep. Yep, one or more containers, yes. Yes, but pods generally means group of whales. You define a group of whales as a pod. It's a group of whales or dolphins or something. You define them as pods. And does it make any sense now? Because whales or something like Docker, right? So Docker's image is whales, right? So that's why it's named as pods. In Kubernetes term, an object that holds one or more Docker containers. So that's what a pod is. Like it does need not be like it can contain only one Docker container. It can contain one or more Docker container running inside it. So that's what pods is all about. And this is a basic building block of all Kubernetes. So if you are doing Kubernetes, this is a basic thing that you have to understand and know. So let's go and see how the Kubernetes architecture itself is running. So which gives you an overview of how this entire system works. There is a brain in Kubernetes for every application that we have. The brain of the Kubernetes architecture is called as control plane. So here where the most of the works happen. So inside control plane, you have certain services that are running, and one of them is API server. Your CLI, your UI, and your API, whatever mechanism in which you are talking to the Kubernetes client or talking to the Kubernetes environment architecture, this is where the entire thing happens. Your API server is the point through which you're going and talking to your Kubernetes. And then you have a scheduler, and scheduler is responsible for scheduling all those stuffs. So you have a pod, you have to create it at some point of time, you have to down your container, you have to restart the container. All those things are done by scheduler. It's basically the namespace, it's a scheduler. And then there is controllers, and this controllers is responsible for running all the resources. So you can, okay, as the namespace, you can say it's a controller, so it controls the entire stuff for you. And finally, you have etcd. Anybody heard about etcd before? etcd. So etcd is an object storage where Kubernetes actually stores all those information. It's just a key value store, just like a map. You can consider that just like a map. But this is where all the configurations, all the things that you deploy, all this stuff end up in this block of storage. So this is where everything is defined. So this is a control plane, which is the brain of your Kubernetes cluster. And then you have something called nodes, which kind of the workers or the people who actually do the practical work. So this control plane just issues some instruction, just like your brain works. And this worker nodes is something that kind of helps or do what it has to do. And the nodes has a list of kubelets inside. So let's drill down and see what is a kubelet and things like that. So you can consider this is a worker node, and you have a proxy. So proxy is something like it handles all the networking to the underlying pods that are running. So in Kubernetes world or Docker world, we always struggle to see like there is some networking problem or the host is not connected, things like that. And this is responsible for that. So this kube proxy is for handling all the networking stuff that you have. And then you have kubelet, and the kubelet is just to monitor the status. And if there is some problem happening in your pods, if you want to reschedule or scale up your containers, and this kubelet is going to help you to do that stuff. So worker node or the plain workers, that kind of helps you to do stuff with the application. And one other thing is like Kubernetes is highly available again. So this is the importance of high availability. Kubernetes is highly available, and just because the nodes, they can spin up any number of nodes in a single Kubernetes, and each node can spin up any number of pods inside it. So which means like any one goes down, the other automatically picks up and does the work that is needed. So that's how Kubernetes is architected. And out of many experiments or speaking to many people, one of the fine conclusion that we made up is like managed Kubernetes is always the best thing because it helps you to do all those activities. Kubernetes, even though it seems simpler at the very top level, but once you drill down inside, there are a lot of different things because Kubernetes has to support various varieties of stuffs inside. So it's kind of complicated. So I would say go for a managed Kubernetes, and if you want to thrill on your journey, you can do it on your own. And a few other core concepts just before we see what are the Kubernetes file that we are generating with respect to Kubernetes. Anybody know what are replicas? It's obviously there. Yep, okay. So it's helpful for monitoring and managing your replicas. You can say like, okay, so I want 3 replicas of this system, and I want 4 replicas of that system. So this replica set is where you define them, and it kind of monitors and manages. So one replica goes down like from 3, it goes down to 2. Then it automatically picks up and say, okay, there is only 2 running, I have to start the 3rd one. So its replica set is basically for that. And you have deployments, and deployments is recorded information of your cluster. So replica set is the one that monitors and manages the pods, but deployments are the one which holds the information. So whenever replica set goes and sees the amount of pod running, it comes back to deployment and checks how many pod that I have to run. If it says 3, then it goes and runs 3. And finally, you have services. Services are nothing but load balancer in your normal world. That's it. So networking. How many of you are familiar with networking in Kubernetes? 1? Okay. So you have 3 different concepts here. One is load balancer, which is similar to load balancer that you have seen. But you have multiple different services that are lying underlying. And on top of it, you have a load balancer service that will be created async. So once your services have started, this load balancer service will be created and it issues an IP, and you connect your applications through that IP. So that's how this thing works, the load balancer. And in terms of node port, you have a master Kubernetes cluster, and it has an endpoint attached to it, so an IP address basically. And you have a list of services that are running, but they all run on different ports. That's the difference here. They don't have any, they have the same assigned IP as the master, but they have different ports in which they run. So that's the difference. And the third one is ingress, which everybody is kind of using it. Every service runs on a different IP address, and you have a controller that runs in front of them, and you access everything through that controller. It's pretty similar to load balancer, but even more, like you don't have any external connectivity that can happen through that service. So even the ingress controller is kind of internal, it's not externally exposed. So that is one of the 3 of the different services. Why do we need this thing? Because when you're architecting a solution on Kubernetes, you need to understand these 3 concepts, because networking is the foremost thing that you have to start with. And anybody know Kelsey Hightower here? Everybody knows him, right? So it's a quote from him. I don't want my Kubernetes slide without his quote. So it's a quote from him. It says like, Kubernetes does the thing that very best system administrator would do. Automation, failover, centralized logging, and monitoring. So these are the 4 important terms in all application development which it tries to do. And it's quite astounding to see that like all the open source effects or all the open source stuff, all the different companies who tried out microservices, put all of them together, bundled it in a single package, and you can use it straightforward. So that is one of the greatest things that you have here. And just before we go to Istio, we will go ahead and see. Yeah, the applications are generated. So what you can do with the application is like you can package them as a Docker application. You can package them, containerize them. And once you containerize, you can tag those images, create an image, tag it, and then publish it to your Docker repository, which can be private or local. And then you just run the single command, which will boot up all the things for you. So for example, I have my Kubernetes running now. So I have my Kubernetes running on my local machine now, and you can see it here, all those services that are running, all those things that are running, and I have a namespace that says JHipster, and it's exactly all the things that I have it inside here. So it's like the invoice with its database, notification with its own database, and all those things. I can go and run this application right at this URL. So it's running on my local, it's running on my local host, and you can see it like, this is a basic application that will be generated by JHipster. So you can see like all those things are here. There are entities that are generated, which creates a CRUD component for you. You can go ahead and create your application here. You can create everything here. And the user management, which is by default is there. It's based on Spring Security. It gives the metrics of your application, and it gives health of all the endpoints in which it's running. And you have an I18N also, like it completely changes the language. So you can add a language and things like that. I've been talking about JHipster registry a bit, but yes. So this is how it is there. And just going back to the slides again. So this is Istio. Anybody Istio? Yeah, okay. Service mesh. Anybody knows about it? I think we also had a talk today on service mesh. Anybody went to that talk? No? Okay. So the term service mesh describes network of microservices that make up such applications and interactions between them. So that's what officially Istio websites describes how a service mesh is. But I would like to think Istio as like, you have certain components inside your application which is mandatory for your services to run. You pluck out all those components, create a component at the center, and make sure the center component connects to all other components. That's what Istio is all about. So you can segregate your application into microservices. When you're doing it, it's based on the domain model. So it's based on like I have 5 different entities, 2 entities live together, 2 more live together, and this one is something that is smaller, which lives again. So this is how you segregate your application. But in terms of Istio, it's like you take all the common functionalities, put it in a single application, make that application to connect to multiple services that are running, which kind of helps you. So pictorially, I don't have that slide. Okay, fine. So what Istio helps you to do? It helps you to connect. So it helps you to connect the flow of traffic between those services. So you have multiple services that are running. It helps you to connect to those services. It secures your application. It kind of goes towards and then it tries to secure your entire application. That's also one of the good things. And then it apply policies on the fly. Since you have plucked out all these important terms and put it in a centralized repository, it tries to apply policies on the go. So it's runtime generated, runtime apply. So you can say like, okay, so I want this particular version of my application to connect from the connections that are coming from Italy or from the connections that are coming from some other place in the world. So you can do that policies and do that at the runtime. So that's one of the major things. And of course, you can trace and monitor stuff. So JHipster also makes it easy to generate Kubernetes and Istio configuration. The way to do it is like using JHipster Kubernetes command. Let's just briefly go through what it generates. So I have this folder, Kubernetes. So you can see it here, the invoice, notification, product, and store. These are the 4 applications that we have generated. It creates a folder for all of those applications. And if you drill down and see, it creates, is it visible? Okay. So it creates a gateway YAML file, which is a gateway that defines a gateway of your application. It defines a deployment, how your deployment should be, how many replicas that you want to have. This is what I meant by replica set. Here I specify 1 replica. And labels are some identifiers in terms of Kubernetes. And how I want to init the container, what are the things that it has to have inside it, and what is the profile that I have to use, and things like that, and the database that I have to connect to. It generates all of those things for you. And you have to look at the URL here to specify an URL, which is a URL that will be generated by the YAML files that I will show you later. So that's one thing. And here again, you have the resources, limits, request and limits. That is also present in which port you have to run. And anybody knows about readiness probe and liveness probe? No. Okay. So readiness probe is something like once your application started, how much longer you have to wait till you find whether the application is ready for connecting and getting information. Liveness probe is like how many beats that it has to give to make sure your application is live or not. So these are the two probes that I think is very crucial, and it really helps you, like service registries, health checkers, all those live on top of it. So here in readiness probe, I say this is my endpoint, and this you just connect with HTTP. Delay for 20 seconds because my application has to start within 20 seconds. Once it is done, every 15 seconds, just go and hit that server. Go and hit that endpoint and see whether the application is working or not. So this is what readiness probe is all about. On the other hand, liveness probe is like, okay, so this is my endpoint again, this is the HTTP, delay for 120 seconds, and then you start doing all those stuffs. So it delays for 120 seconds, and then it starts doing all those stuff. So that is what readiness and liveness probe. So this is my SQL server, and here you have a service, and this service is where I've defined this name. Based on this name, URL gets generated. So this is very crucial part of the application, because here you define a name, and this name is set as your URL, and which will help you to connect to the underlying services that you're running. And similarly, the one other important thing is notification, which because it has MongoDB, so you can go ahead and see like it creates a MongoDB specified config, and it also creates a config map and then puts all those information. When you shut down a MongoDB, what are the things that you have to do, all those best practices, it tries to encompass and put them together. So that's how this entire application has been architected. But do we have time? Okay. So just moving back to slides, and this is the final part of the presentation, the best practices that you have to follow when you're doing Kubernetes and Istio. The very first thing is like YAML files. You have seen the YAML files. We always want to have those YAML files smaller, as small as possible, because YAML files are #1 source for your errors. You miss a space, you get an error. So probably be aware of it. Try to reduce your YAML files into smaller stuffs, which really helps. If it's bigger, split it. Split it into multiple chunks, split it into different YAML files, name it correctly. For example, if you go back here and see, so a deployment has its own YAML file, a service has its own YAML file, database has its own YAML file. So you have to specify all those YAML files separately. Of course, single responsibility principle appeals here also. Like you have to understand like all your YAML files has to do a single stuff. Faster boot time for images, because you always on the fly you have to have faster boot time on the images. How you can achieve it? Smaller image sizes, alpine images. Everybody knows about alpine images, right? Yeah. So smaller image sizes is really required. That's one of the other things. And think of this thing like try to do a builder pattern. Always have a smaller image size and then try to build on top of it, which kind of helps you out. And the other thing is like all the node size should be 5 to 10 pods per node. By default, a typical Kubernetes node can handle up to 110 pods. You can increase the size even to 500, but you mean that doesn't make any sense. But always have 5 to 10 pods running on the node. If it's more than that, then increase the number of nodes that you have. Anybody knows about healthy zombie? It's healthy or zombie. It's not healthy and zombie. Okay, so if a Docker container can handle any processes that is running inside, you can run like hundreds of processes inside the same Docker container. But the problem is like once one process goes down, the Docker container doesn't know which process went down. So that is a problem. Like when you have an application and you depend on that endpoint, you go and check. The application always say that's healthy, but there is underlying dead process inside, and that dead process will cause disruptions in your application. So that's what is healthy zombie problem, and you have to consider run a single process in a container. That's the best minimum that you can do. Services always use red pattern. What's a red pattern? It's like request, error, duration. So all your services measure it based on request, number of errors it gives, and the duration in which it runs, in which it responds. So measuring all those things, you can give a better services. And for resources, use pattern. Utilize saturation and errors. Always record your history. And I've shown you request and limits. Always try to use request and limits, because every container that you're running has to given a request, because if you're not giving a request, then you might end up that single container blocking all the memory, but it need not have that stuff. Clean up unused resources, that's a basic thing. Monitor and tune, this is very important thing. Always try to monitor and find out where you are actually having a problem and then try to tune things with that. Any questions? Yep.
Which is the best way to deploy Kubernetes application which are using WebSockets?
I think, okay, so Kubernetes is actually architected, it doesn't have to impact on any architectural decision that you take. But again, if you're talking about WebSockets and things like that, it's better in terms of on what reality you want a better service, or how do you qualify your service as a better service? Like, what is your measurement of better thing? Sorry, okay, can you repeat the question again?
Yes, in which way can I deploy an application Kubernetes? An application which are using the WebSockets, because when I open WebSocket, I need to go on the same machine. If that container of code are going down, I lose my connection.
Okay, that's okay. So for yeah, I get you there. But for WebSockets, it's ideal to have this thing. Okay. I'll get back to you on this. I cannot think of a solution now, but we have used a similar approach in our company, so I know how this thing has to work. I'll talk to you later. Fine? Okay. Yes?
Were those YAML files that you showed created by JHipster or Istio?
It's created by JHipster.
By JHipster.
Yeah.
So what's the role of Istio in your use case?
Yes. So I do have this entire application runs on top of Istio. So you have seen like so here you have seen that I've not chosen any service discovery. There is no service discovery, which means there is no console, there is no Eureka server that is running, and Istio is actually taking care of that thing for me. So it kind of like acts as a service discovery agent, and all the requests that I'm sending it to is going inside the Istio, because I've given this domain for the Istio, and all those things goes inside that domain. And this is where the Istio routing takes into account. So everything that I route is through Istio. So I don't need to have any service discovery attached to my services. Istio takes care of that part for me.
So JHipster uses Istio, right?
Yes.
It's similar to something that already does Docker Compose, right?
Yes, it's similar to Docker Compose, but JHipster is an application constructor, you can say, application generator. That's something quite different from Istio as well as Docker Compose. So Docker Compose and Istio are the technologies that we use to deploy our applications, and that we have it here. Yeah. Any other questions? Okay, so I've also done a book on full stack development with JHipster, and if you're interested in full stack development, you can go ahead and get this one. Here we discussed how to use JHipster, how to migrate from monolith to microservices and things like that. So, and thank you for your time.